Hello everyone, and welcome back to our channel. This is episode 68, and today we tackling a problem that almost every developer and operations team has faced: the absolute chaos of scattered configuration files and keys. Imagine you have dozens, maybe hundreds of microservices. Each one has its own set of keys, passwords, API tokens, and database credentials. They're everywhere in config files, environment variables, sometimes even hard-coded. It's a mess, right? It feels like you're juggling a giant ring of keys, and if you drop just one, the whole system could be compromised. We often think of our code or our data as the core asset, but I'm here to argue that the real crown jewel, the true core asset, is the key cabinet itself. How we manage access is what truly defines our security posture. So let's dive into some key concepts we'll be discussing today: security, key management, and the role of configuration centers. Security isn't just about building tall walls. It's about controlling the gates. Who has the keys? How are they used? Key management is the practice of handling these digital keys throughout their lifecycle: creation, use, storage, and deletion. A configuration center is a centralized service designed to manage all this sensitive information in one secure, accessible place. Think of it as the ultimate solution to our scattered keys problem. It's not just about tidiness. It's about robust security and operational sanity. We're moving from a world of digital chaos to one of organized, controlled access. This shift is fundamental for any scalable and secure system. To make this crystal clear, let's use a simple logistics metaphor. Imagine you run a massive company with hundreds of warehouses. Each warehouse has a key. If you give a physical key to every employee who needs access to a specific warehouse, you'll quickly have thousands of keys floating around. What happens if an employee leaves? Do you get the key back? What if a key is lost or copied? A thief wouldn't need to break down the door. They just need to find one lost key. Even worse, what if there's a master key that can open all warehouses? If that single key gets leaked, your entire business is at risk. This is exactly what happens when we scatter our digital keys across different services. Each config file is a potential point of failure. Now, how do we solve this in the physical world? We'd use a central key cabinet, probably inside a secure room. This is our configuration center. Instead of handing out keys to every warehouse, you give authorized personnel access to the key cabinet. When someone needs to get into warehouse 12, they go to the security office, verify their identity, and check out the key for warehouse 12. Their access is logged: who took the key, when they took it, and when they returned it. This is our access audit. The key cabinet itself is a high security safe. It is much easier to secure one safe than it is to secure hundreds of individual warehouses spread across the country. This centralized approach dramatically reduces the risk of a breach and gives you a clear, auditable trail of who is accessing what. Let's bring this metaphor back to our tech world. The core insight here is that storing keys and sensitive configuration information in a dispersed, scattered manner exponentially amplifies the risk of leakage. Every service, every environment, every developer's machine with a config file becomes a potential attack surface. A single compromised laptop or a misconfigured S3 bucket could expose credentials that unlock critical parts of your infrastructure. It's a game of whack-a-mole, and the odds are not in your favor. You can't effectively audit who has access to what because the information is everywhere. It's like trying to track thousands of physical keys spread across the city. It's impossible. Centralized key management, using a configuration center, completely changes the game. It's like having that one secure key cabinet. Suddenly, the question of who can open which door becomes incredibly clear and manageable. You define access policies in one place. Want to grant the billing service access to the payments database? You configure it in the central system. Need to revoke a developer's access when they leave the company? You disable their credentials in one place, and their access to all systems is instantly cut off. This single point of control is incredibly powerful. You have a single, unified audit log. You can see exactly which service requested which secret, and when. This visibility is crucial for security compliance, incident response, and debugging. You're no longer guessing. You have concrete data. The benefits don't stop at security. Think about operations. When you need to rotate a database password and you should be rotating them regularly, the old way is a nightmare. You have to go into every single service that uses that database, update the configuration, and redeploy all of them. This is risky, time-consuming, and prone to error. Miss one service, and it breaks. With a configuration center, you update the password in one place. The next time the services need the password, they fetch the new one automatically. No redeployments, no downtime. This agility is a massive operational win. It transforms a high-risk, painful task into a routine, low-risk operation. It empowers your team to follow security best practices without creating a huge operational burden. So, what do these configuration centers look like in practice? There are many great open source and commercial solutions out there. Tools like HashiCorp Vault, Oz Secrets Manager, Google Cloud Secret Manager, or Azure Key Vault are all designed to solve this exact problem. They provide APIs for your applications to securely fetch secrets at runtime. They handle encryption, access control, auditing, and secret rotation for you. For example, your application, instead of reading a password from a local file, would start up, authenticate itself to the configuration center using a trusted identity and request the secrets it needs. The secrets are then delivered securely over the network and often held only in memory, never written to disk. This significantly reduces the attack surface. Implementing one of these systems is a foundational step towards building a mature, secure, and scalable architecture. It's a project that pays dividends in security, operations, and developer sanity for years to come. But let's not get ahead of ourselves. While a centralized system is incredibly secure for today's operations, the tech world never stands still. Tomorrow, you might face a new challenge, what I call moving warehouses. You might need to migrate from one cloud provider to another. Or maybe you're moving from a self-hosted database to a managed cloud service. This means all your connection strings and credentials need to change. This brings us to a huge topic, data migration. How do you move petabytes of data from one warehouse to another without shutting down your entire operation? How do you ensure that during the move, every application knows exactly where to find the data, whether it's in the old location, the new one, or both simultaneously? It's a complex dance of coordination and engineering. And that's the teaser for our next episode. We're going to dive deep into the world of zero downtime data migration. We'll explore strategies like dual writing, data reconciliation, and traffic shifting that allow you to pull off these massive infrastructure changes seamlessly without your users ever noticing a thing. It's one of the most challenging, but also most rewarding tasks in modern engineering. So, if you found today's discussion on centralized key management helpful, make sure you hit that like button. It really helps the channel. And if you don't want to miss our next episode on a crash course in data migration, be sure to subscribe and turn on notifications. Thanks so much for watching, and I'll see you in the next one.